Hi folks, this is question 10 and it's the last question. So we've got three diagrams here and they're just looking for us to draw T4 in the grid. So you're just putting rectangles onto the triangle really. So this one will have to have 4 rectangles. So every 2 squares you're going to draw a rectangle. Try and make that a bit clearer. So that's the first one. And then we go up 2 more boxes. Right, so you get the idea anyway. So that's all you have to do. Right, show that the total area of the 3 rectangles in T3 is 32/3 square units. So area of the 3 rectangles. So the length of each of those rectangles will be well, we don't know all of them. So if you look at T3 there, if you just look at the bottom rectangle on it, okay, just look at the length of the bottom. So just look at the length of that rectangle. The length will be the same as the base of the triangle, so that'll just be 2. So we must do 2 multiplied by the width of the rectangle. The width of the rectangle would be 8 divided by 3. And that's the rectangle, that's the length multiplied by width for the bottom rectangle. If you look at the middle rectangle, that's going to be, the length of it would be 2/3 of 2, because it's 2/3 of the base of the triangle, and you have to multiply that by 8/3 again, so the width won't change. So this is the width and this is the length each time. So add on then the length and the width of the top rectangle. The length would be 1/3 times 2, so 1/3 of 2. Yeah, and then the width would be 8/3. And then if you multiply all those things together then, so I should really have that down here. So we end up getting that down. If you put all that in the calculator, you should get 32/3. So that's it. That's part B. Find the total area of the n rectangles in T of n. So give your answer in square units in terms of n in its simplest form. Right, so if you look at the area of the first one, okay, so area there would just be 2 multiplied by 8, so that's just going to be 16. So that's the area of the first term, or the first kind of rectangle. The second one then, if you just look at the bottom rectangle there, bottom of it will be 2, and this will be, the width of it would be 8 divided by 2, which is 4. And then if you look at the, well, it'll still be 4, but then the bottom of that rectangle has to be 2 divided by 2, which is 1. So therefore you do 4 times 2, which is 8, times by 4, which is 32. Okay, so we're getting 16 and 32. And then 32 over 3. Yeah, so we have to develop a sequence from this. So I'm just going to call sorry. I don't think that's always going to work. Right, so I'm going to break it up into. So if you look at just T3 here for a second, so the height there, so the width, the height of each of those little rectangles in there, if you break it up, so they should all be the same because it's always the same angle, and they're all, yeah, so the distance from there to there will always be 8 divided by whatever the term is in the sequence. So here it's 3, but it'll always be 8 over n. So the other part, so the width of each of those little rectangles is harder to see, but it's going to be so the whole distance across the bottom is 2. So in this case it would be 2 divided by 6, but that's the same as 1 divided by 3, and in this case n is 3, so it'll always be 1 over n. So that's the width of one of the little rectangles, that's the length of one of the little rectangles. So if you think about it here, if you look at all the rectangles there in T3, so the height of each of those rectangles, or the kind of the length of each of those rectangles each time, has to be it'll always be 8 divided by whatever n is. So in this case it's divided by 3, but for the last sequence it'll be divided by 2, and so on. So if you think about the width of each of those little rectangles, then, so that width in there, well, the whole way across for T3, the whole way across here would be 2, and it's being divided by, in this case it's being divided by 6. Now that's the same as 1 over 3, but note that 3 is the same thing as n in this case because it's T3. So therefore that will always be 1 over n. So for one little rectangle it would be 1 over n multiplied by 8 over n. So that then, that's the area of one little rectangle, but we need to multiply that by how many there's going to be. So if you count them up here for T3, so if you count those two on the end, that one and that one, that's 2, and then if you go in one more, and then there's 4 there altogether, so that's plus 4, and then there's going to be 6 there left. Okay, so 2 plus 4 plus 6, and so on for how many there is. So 2 plus 4 plus 6 plus all the way up to n, and that will form a sequence. Then you can take 2 out actually, so 1 plus 3, 2 plus 3 all the way up to n, and then that's just a natural number. So we have something in terms of n that we can say for that. So it's so we can call that 1 over 2 times n times n plus 1. That's just the general form of that sequence, the natural numbers going up one by one. Multiply all that by 1 over n, and multiply that by 8 over n. So that n and that n will cancel out, and then the half and the 2 cancel out. So we're just left with 8 times n plus 1 over n. So that should be it then. You can call it 8n plus 8 over n if you want. Okay. Right, so for part D anyway, we can come up with an inequality because, so that is the total area, 8 times n minus 1 all over n needs to be greater than 95% of it. So you do 16 multiplied by 95% on the calculator just to find out what 95% of 16 is. Actually it's not 16, it's 8, because the area of that triangle is half times base times height, so half times 8 times 2 will be 8. So we're looking for 95% of 8, and that will be 7.6. So we get that inequality, bring over the n and multiply it, so we get 7.6 n is, and then on the left hand side we get 8n minus 8. Bring over to 7.6, you'll just be left with 0.4n is greater than 8. So then you can just, you don't need to worry too much about the inequality sign in this. N is greater than yeah, bring it over and divide it. Yeah, you're going to get 20. So n is greater than 20, but we know that n has to be a natural number, or an integer, well, natural number. So then n is equal to 21. So it's that's the first value of n for which it's greater than 95% of it. So that's it. Right, so last question then, or last part. So yeah, we have to integrate s of x anyway. So x squared c squared over h squared. So it's with respect to x here. So therefore you can kind of forget about the c squared and the h squared for a second. So you can leave them outside, and it'll just be x squared that you're integrating. So it'll just be x cubed over 3, and then between h and 0. So if you put a h in, you get h cubed. So it'll be c squared over h squared, c cubed over 3. They're just being multiplied by each other. Minus then, and then if you put a 0 in, yeah, you won't get anything. Because it'll, yeah, because everything's being multiplied by 0. So I'm getting oh no, I didn't. I put the wrong thing in, didn't I? I put a H in, I put a C in instead of a H. So it should be H there. So we get, yeah, that looks better. So we get just a h on top. Should be a h there, looks like an n. We still have c squared, and we still have 3. So use integration to find the volume of the pyramid in cubic units in terms of both c and h. So I think that's all we have to do. Right, so last part then, we're going to be changing variables a little bit. So x starts to increase at a rate of 3 units per second. So that's straight away we can call that dx, and it's in terms of time, so dt is equal to 3. So we can say dx dt is equal to 3. Right, so it's one of these ones anyway. So we're looking for find the rate of change. So rate, we know it's differentiation of s of x with respect to time. So it's ds in respect of time, so dt. And then it's one of these things where we've got an x involved as well, we already know from the first bit. So it'll be ds dx multiplied by dx dt. So the x's would cancel and we can get ds dt from that. So ds dt is what we're looking for. So we already know what dx dt is, we just need to get what ds dx is. So we know that s is x squared c squared over is it h squared. So we want ds dx, so ds with respect to x. So kind of forget about the c squared over h squared. It'll just be c squared over h squared multiplied by 2x, because you just reduce down the power of x and multiply it by 2. So that's what ds dx is, and then so it's just all of that multiplied by 3 really. So it's c squared over h squared multiplied by 2x multiplied by dx dt, which is 3. Now also we wanted when the perpendicular height of the pyramid is when x is half the perpendicular height of the pyramid. So x is half of what h is. So therefore x is h over 2. So c squared over h squared multiplied by 2 times h over 2. Just 2h over 2 really. And then that's all still to be multiplied by 3, and then those things in the middle should cancel. So h cancelled, but one of the h's on the bottom. The 2's are just gone. So we're left with c squared 3c squared over h. Yep, that's what I got. Right, so that's it. That's all for question 10, and that's it for all of 2023 higher paper 1.